Jai Hind children, continuing with the areas related to circles. A new topic or the last topic of the chapter we are going to start areas of combination of plane figures. So far we have calculated the areas of individual plane figures such as rectangle, square, circle, etc. In our daily life, we come across various plane figures which are combination of two or more plane figures. For example, window design. Look at this window design. It is a combination of rectangles and squares. Individually, you can find the area of a rectangle as well as a square. But here, the design is a combination of rectangles and squares. Look at another design. It is a combination of a circle and a rhombus or a square, whatever it may be, you can think. Now, we are going to study how to find areas of such combined figures. After doing problems, you will get a clear idea. Okay, now we can start with the problems in this section. Of the shaded region in the figure. A figure is given here. You are asked to find the area of the shaded region. I think that you can see what the shaded region is in the figure. The condition given is that PQ equals 24 centimeter. The length PQ is given as 24 centimeter. PR equals 10 centimeter. The length PR is given as 10 centimeter. And O is the center of the circle. Use the value of pi as 22/7 throughout this question. Okay. At first you need to identify what is the shaded region. I told you that when you are given with a combination of plane figures, here the given figure is a combination of a circle and a triangle. At first you need to identify the plane figures in the combination figure. Now you need to think what the shaded region is. That is the second step. Here QR passed through the center of the circle. Am I right? Here QR passed through the center of the circle. Passed through the center O. Center O. Hence what you can say, therefore QR is a diameter, which implies QR is a diameter of the circle. Now we can identify the shaded region. Look at the figure. Actually, to get the shaded region, now need to consider the full circle. QR is a diameter and hence this much part will be a semicircle. So, from this semicircular region, if you subtract this triangle PQR, you will get the shaded region. Am I right? From the semicircular region, the downward semicircular region and upper semicircular region as well as the down semicircular region you can see. So, the downward semicircular region you need to consider, the full region you need to consider, and from this if you subtract the triangle PQR, listen to this, if you subtract the triangle PQR from the lower semicircular region, you will get the area of the shaded region. Therefore, identify that at first. Area of the shaded region equals area of the shaded region equals area of the semicircle, area of the semicircle minus area of triangle QPR. But angle P equal to 90 degree. Why? Angle P equal to 90 degree. Why? Last year you studied that angle in a semicircle is 90 degree and this is the angle within a semicircle. Reason angle in a semicircle. Angle in a semicircle is 90 degree. If this angle is 90 degree, what about triangle QPR? Therefore, triangle QPR is a right triangle. Is a right triangle. If triangle QPR is right triangle, we can apply Pythagoras theorem. Therefore, by Pythagoras theorem. Therefore, by Pythagoras theorem. What Pythagoras theorem states? Hypotenuse square equal to base square plus altitude square. This is Pythagoras theorem. I am going to substitute the values here. Actually, what is hypotenuse? 90 opposite side is the hypotenuse. So, QR is the hypotenuse. So, QR square equal to. What is the base here? The base is PR square plus. What is the altitude here? Altitude is QP square or PQ square. All are correct. Now, we can substitute the values. You need to find QR equals. The value of PR is 10. I am going to substitute here. 10 square plus. The value of QP is 24. That I am going to substitute here. 24 square. Which is equal to 100 plus 24 square is 576. From this, you can say that therefore, QR equals 500 plus 576 is 676. That is QR square. QR square, the left side is QR square. QR square equals 676, which implies QR equals square root of 676, which is 26 centimeter. So, QR equal to 26 centimeter. Therefore, what you can say, the diameter of the semicircle is diameter equal to 26 centimeter. What is QR? QR is actually the diameter of the semicircle. Why I found the diameter? Why? Because I want to get the radius of the semicircular region for to get the area of the semicircular region. So, for to get the radius of the semicircle, diameter divided by 2 is the radius. Am I right? Which is equal to 26 by 2, that is 13 centimeter. So, radius of the semicircular region is 13 centimeter. Thus, the diameter obtained to is diameter equal to 26 centimeter. If diameter equal to 26, we can say that the radius as 13 centimeter. Radius 13 centimeter. Now, I am going to mark the radius 13 centimeter, the given figure as 13 centimeter. 13 centimeter the radius. This much is 13. We are going to find the area of the shaded region. Area of the shaded region equals area of the semicircle. Area of the semicircle, downward semicircle, you need to consider area of this semicircle minus area of this triangle QPR. This much triangle area we need to subtract. Area of triangle QPR. But we know that this triangle is a right triangle, and hence I am going to substitute the formula here. Area of a semicircle, the formula is area of a circle is pi r square. Area of a semicircle is half pi r square, where the radius are obtained to as 13, that we need to substitute in the formula, minus triangle QPR is a right triangle. So, its area can be found out by using the formula half into base into the altitude or the height. I am going to give the values here. Base given to as 10 centimeter and the altitude or the height known to as 24. So, h equal to 24. Now, we are going to make the simplification. Half into the value of pi is 22 by 7 into the radius r square is 13 into 13 minus half into the base is given as 10 into the altitude or the height is given as 24. Okay, we can do the cancellation. 2 cancel with this 22 11 times. No further cancellation. So, remaining here is 11 into 13 divided by 7 minus. Here 2 cancel with this 10 5 times. Now, the remaining is 5 into 24 remains there. I am going to multiply, which is equal to which implies 11 into 13 into 13 is 169. So 169 into 11 is 1859 by 7 minus 5 into 24 is 120. Listen to the calculation, which implies 1859 divided by 7 is 265.57. 265.57 you will get minus 120, you know, to subtract. Subtracting you will get the answer 145.57 centimeter square is the answer. So remember how to find the area of this shaded region. Okay, come with problem 2. Find the area of the shaded region in the figure if ABCD is a square of side 7 cm. The side of the square is given as 7 cm. This side also 7, because you know that all the sides of a square are equal. So 7 cm is the length of the side. And APD and BPC are semicircles. Look at this, APD, a left side semicircle, and BPC, a right side opening semicircle. So two semicircles are also given here. You are asked to find the area of the shaded region in the figure. I told you that at first you need to identify the figures which are associated with this combination of plane figures. Here, the given figure is the combination of two semicircles and a square. Am I right? Two semicircles and a square. Then, at first we need to find the required region or required area. Here, the required area equals. What is the required area? These two semicircular areas you need to sum up and then subtract from the area of the square. Am I right? So, area of the or required area equal to area of the square. From the area of the square, you need to subtract area of the two semicircles, you need to subtract. That is area of the semicircle APD, the left side semicircular area, plus area of the semicircle one more semicircle given here, BPC. Two semicircular areas you need to subtract. Okay. For to find the area of a square, you know that we want the side. At first I am going to write what about the side of the square. The side of the square equal to 7 centimeter. 7. If the side is 7, can I say what about the diameter of the semicircle? Diameter of the semicircle actually equals the side of the square. Am I right? Side of the square. So, diameter of the semicircle here, diameter of the semicircle equals. What is the length of the side of the square? 7 centimeter. If the diameter of the semicircle is 7, what about the radius of the semicircle? Therefore, the radius of the semicircle equals half of this 7 or 7 by 2 centimeter. This we want, the radius of the semicircle we want, and the side of the square also we want, that is 7 centimeter. Now, I am going to find the area of the square at first. Area of the square. This we can take equation number 1. Area of the square equals side into side. Side into side. What is the side of the square? 7. 7 into 7, which is 49 centimeter square. So, area of the square is 49 centimeter square. Now, I am going to find the area of the two semicircles. Area of semicircle, the first semicircle APD equals. What is the formula for to find the area of a semicircle? Half pi r square. What is the radius r in the question? The radius r equal to 7 by 2. Okay, I am going to substitute the values, which is equal to half into the value of pi is 22 by 7 into the radius r is 7 by 2 into 7 by 2. We need to substitute. So that 2 cancel with this 22 11 times. 1 7 cancel with this 7. Now the remaining is 11 into 7, that is 77 divided by 4 centimeter square. Area of the semicircle APD equals 77 by 4 centimeter square. So the same will be the area of the semicircle. The right side semicircle, what is the right side semicircle? BPC. So BPC also has the same area, 77 by 4. So APD semicircle area 77 by 4. The same area for BPC also 77 by 4. So from the full area we need to subtract these two 77 by 4. We need to subtract. Therefore equation 1 becomes. Equation 1 means we need to substitute the value. Equation 1 becomes area of this square. What is the area of the square? Area of the square obtained to us 49. Required area equals. Required area equals. Area of the square obtained to us 49 minus area of semicircle APD. What is the area of semicircle APD? 77 by 4. Don't forget to put the bracket there. 77 by 4 plus the same will be the area of the semicircle BPC. That also 77 by 4. Now we need to simplify this. You will get 49 minus. What is 77 by 4 plus 77 by 4? 2 times 77 by 4, which is 154. Either you can take it as LCM. 154 divided by 4 we can do. Or you can write it as, which is equal to 49 minus. What is 154 by 4? 154 by 4 equals 38.5. 38.5. So subtracting, you will get the answer as 10.5 centimeter square is the final answer. 10.5 centimeter square. So very simple the calculation. Required area means from the full area of the square, you need to subtract these two semicircular areas alone. Okay. Now need to note down the homework questions. Exercise 12.3, question number 1 and question number 3. You need to finish as homework. Thank you.